Okay, in this video what we're going to do is we're going to explore some of the different types of angle relationships. Now, last year you would have learned how to classify different angles based on their size, so things like acute, obtuse, right, or straight angles. What we're going to look at this year is how to put different types of angles together and to look at the relationships between different types of angles in order to find the value of missing angles. So the first type of angle we're going to look at is what is known as complementary angles, and you probably know these from before. Complementary angles are two angles whose sum is 90 degrees. And so we'll just draw kind of a quick picture of that using our tools here. So the first thing I'm going to do is I'm going to draw a perfectly vertical line, and I'm going to draw a perfectly horizontal line. And so this here is 90 degrees, and we're actually going to quickly prove that by measuring it. So I'm just going to quickly select 3 points, and I'm going to say measure angle, and I'll get a measurement here of 90 degrees. And so what I'm going to do now is I'm actually just going to sort of put a line to cut this 90 degree angle into two pieces. And so here's that piece right there. And so now I'm going to measure both of those smaller angles that have been made. So there's 1, 2, 3. We'll measure that angle here. And I'll just kind of put that in the middle, 48 degrees. And I'll do the other one here, D, B, C. And I'll measure that one, 42 degrees. And so you can see 48 plus 42 is 90 degrees. And the cool thing about Geometry Sketchpad is I can move this around. So as I move them, you'll see that one angle gets bigger and the other angle gets smaller. 40 plus 50 is still 90 degrees. 60 plus 30 is still 90 degrees. So what I've done is I have now created a pair of complementary angles. The second pattern we're going to look at, or the second pair we're going to look at, are what are called supplementary angles. And the only difference between these is that these are two angles, and I'll use the angle symbol here, supplementary angles. Those are two angles, and note that the key is two angles, not three, not four. Two angles whose sum is 180 degrees. And so we're just going to use this same sort of diagram here, and we'll turn this into some supplementary angles. So first of all, I'm just going to move all of this over to the side, and now I'm just going to take this angle and I'm going to kind of move it down here. So I'm going to get at the bottom a sum of 180 degrees. And now you can kind of see that I've got two angles, one's 150 and one's 30. 150 plus 30 is 180. Again, no matter where I move this particular line, however I break this angle apart into two smaller bits, the sum of the two smaller angles is always going to equal 180 degrees. The third and fourth types of angles we're going to look at are what are known as vertical angles and corresponding angles. And these are a little bit more complicated. To see these, we need to actually draw a much sort of more complicated type picture. So we're going to do that right now. And the first thing we're going to do is we're going to draw two parallel lines. Parallel lines are lines that will never ever meet no matter how far in the distance they go. So these actually technically are parallel segments because they end. And I'm going to make another sort of segment or line that kind of cuts these. And this particular line or segment in this case is what is known as a transversal. This is a transversal. And what it means is it cuts parallel lines. So what this does is this creates sort of two different intersections of angles. So at the top we have an intersection here that's 1, 2, 3, 4 angles, and at the bottom we have another intersection of 1, 2, 3, 4 angles. And it's these intersections that and it's in these intersections where we find our vertical angles and our corresponding angles. So let's focus on the vertical angles first. First of all, vertical angles, they are always opposite one another, and they are always congruent to one another. Now, congruent is a word that you might not remember, and congruent means that they are exactly the same, and the symbol for that is an equal sign with a little squiggle on the top. That means that it's congruent, and it means they are the same size. They are the same size. So if we look at the top angle here, we can actually see that, I'll just give these numbers. Angle number 2 and angle number 3 are vertical angles. They are opposite one another in the intersection, and they are the same size. And by the same token down here, I guess we can call this angle 5 and angle 6. They are also vertical angles because they are opposite one another in the intersection, and they are the same size. And to round things off, we have another pair of vertical angles in each intersection, angle 1 and I guess angle 4 and angle 7 and angle 8. And I probably should have done a better job of numbering those, but you can kind of see now these different pairs. Corresponding angles are a little bit different in the sense that they are found in different intersections, but they are in the same position, and we'll talk about that in a second. And they are also congruent as a result of this. So let's take a look and see what we kind of mean by this. So once again, if we look at the top angle here, we can see that we have 1, 2, 3, 4 angles in the top intersection, and we have 1, 2, 3, 4 angles in the bottom section. If we look at angle number 1, angle number 1 is what I would say in the top left sort of quadrant, or the top left section of this intersection. Well, angle 7 happens to also be in the top left section of its intersection. So angle 1 and angle 7 are corresponding angles, and therefore they are the same size. Likewise, angle number 2, which is in the top right, is in the same position as angle number 5. So those are corresponding angles that therefore are also congruent. Now, we can use these relationships to help us find the value of missing angles. So what we're going to do is we're going to make an example of what that might actually look like. So let's say, for example, we are told that angle 2 is equal to 120 degrees. So using these different relationships of vertical angles and corresponding angles, we can quickly find out the size of other angles. So since angle 2 is 120 degrees, and we know that angle 2 and angle 3 are vertical angles and therefore congruent, we also know that angle 3 is equal to 120 degrees. So this allows us to find those two values. Angle 5 happens to be corresponding to angle 2 and therefore congruent. So angle 5 is also 120 degrees. And angle 6, which is vertical to angle 5, or angle 6 is corresponding to angle 3, therefore is also congruent and also 120 degrees. Now, to find the value of the angles in orange, we need to use a different relationship. And the key here, remember, is that angle 1 and angle 2, angle 1 and angle 2 are supplementary. And if you remember, supplementary means that they have a sum of 180 degrees. So really what we know is we know that angle 1 plus angle 2 equals 180. And now let's fill in what we know. Angle 1 we don't know, so that can be our variable. Angle 2 we know is 120 degrees, and that equals 180. We can use some equation solving by subtracting 120 from both sides. N equals 60 degrees. So now that we know that angle 1 is 60 degrees, we can use the same sort of relationships of vertical angles and corresponding angles to fill in the rest of the missing angles.